Well, welcome. In this video, we're going to be looking at how to determine if an inverse is a function. Now let's start with just functions. Remember that earlier on this year we talked about functions and we talked about how to look at a graph to determine if that graph represents a function. And we did that by using the vertical line test. Remember the vertical line test, what it would do is if I'm looking at a graph, if I draw a vertical line anywhere in that graph and it passes through just one point, I know that graph represents a function. Now, if I wanted to find out if the inverse was a function, one way I could go about doing that would be to graph the inverse. Remember we talked about that in the previous video. We said that if you reflect a graph over the line y equals x, you'd get its inverse. So I could take the time to do that, and then looking at that new graph, I could do the vertical line test again. That's a real pain. I don't want to have to do that. So there's got to be a better way. Well, there is. It's called the horizontal line test. What is that all about? Well, if I'm looking at a graph and if I want to see if the inverse of that graph would be a function, I draw a horizontal line. And I keep drawing horizontal lines and make sure that that horizontal line only passes through one point in the graph. If anywhere it passes more than one point, the inverse is not a function. So again, let's keep these two straight. If I'm looking at a specific graph, I can use the vertical line test to see if that graph is a function. If I want to see if the inverse for that graph is a function, I use the horizontal line test. As long as that horizontal line goes through only one point, the inverse is a function. Let's look at some examples so we can make sense of this. Okay, so let's look at this first example on the far left. Now the instructions tell us to determine whether the inverses of the graph functions are also functions. So when I look at that graph, it clearly fails the horizontal line test. No matter where I would draw a horizontal line, it's going to hit more than one point on that graph. So that tells me that the inverse of this is not a function. Now the next part, part B, says to state the domain and range of each function. So let's review how we find domain and range when we look at a graph. The way that I like to think of it is, remember the x's, or the domain is a set of x's that are graphed. So what I like to do is, imagine if I took and squished the graph on the x-axis. What would the graph look like? Well, if I took this graph and squished it on the x-axis, I would have a line with an arrow going in both directions, meaning that every point on the x-axis is being used. So I would say that my domain is all real numbers. The range, remember, is the set of y values that are being graphed. So if I did the same thing, if I took my graph and if I squished it on the y-axis, this time I would end up with a line segment. We'd have a segment that would start at -3 and go up to 3, but not beyond that, or not below that. So therefore, how would we write that? Well, we could write it using an inequality. So we would say, so -3 and 3 are being included, so we would use less than or equal to, and the set of y's are being included between those points. So it'd be -3 is less than or equal to y, which is less than or equal to 3. Now in part C, it says to state the domain and range of each inverse. Well, recall from the previous video, which I hope you watched, in that previous video we talked about how the domain and range switch when we work with the inverse. So what was the domain is going to be the range for our inverse. What was the range is going to be the domain for our inverse. So in this problem, since the original range went from -3 to 3 on the y-axis, for the inverse, it's going to go from -3 to 3 on the x-axis. We would say -3 is less than or equal to x, which is less than or equal to 3. And since the domain for our original function was all real numbers, that now becomes the range for our inverse. So now the range would be all real numbers. So now let's take a look at the one that we have here on the far left. Now with this one, if you draw a horizontal line, no matter where we draw a horizontal line, it always only hits the graph in one place. So this is one where it does pass the horizontal line test, so yes, the inverse of this would be a function. Now this one's also unique because if I took and if I squished the graph that I'm looking at right now, if I squished it on the x-axis, you'd get a line going in both directions, meaning that the domain is all real numbers, just like the previous one. However, if I took this graph and squished it on the y-axis, that would also result in a line going straight up and down with an arrow on both ends. So the range for this is also all real numbers. So now if I switch these two around for my inverse, you get the same thing. You get that the range, or the domain and range, would also be all real numbers for the inverse of this function. So those are two that we've done together. Now I'm going to pause this video, and I want you to try the two that we have here. So I will hide this little video of myself so you can see that. But I want you to try these next two to see if you can figure out whether or not the inverse of these are a function and what the domain and range for both the original and the inverse of the functions would be. So go ahead and pause the video and see what answers you get. And then hit play when you're ready to check your answer. Okay, so let's see how you did. For the one in the top right, what you should have gotten is that no, the inverse of that would not be a function. And you should have gotten the domain for that would be all real numbers. And the range would be everything less than or equal to 2. And then for the domain and range for the inverse, those two would switch. So you'd have a domain where x is less than or equal to 2 and a range that is all real numbers. And the graph below that, you should see that that fails the horizontal line test, so the inverse is not a function. And then you can see that the domain would be all real numbers and the range would be everything less than or equal to 2. So that means for the inverse of that, that domain and range would switch. So it'd be where x is less than or equal to 2, and our range would be all real numbers. So there you have it. That is how we can determine what the inverse of a function is, and also even how to find the domain and range for that inverse. So with that, good luck now as you work on your assignments.